Okay, question number 4. A department store manager is planning to move some cement spheres that have served as traffic barriers for the front of her store. She is trying to determine the relationship between the mass of the spheres and their diameter in meters. She knows that the density of the cement is approximately 2,500 kilograms per cubic meter. So A says write a function that represents the relationship between the volume of a sphere and its diameter. Explain how you determine the equation. So, necessary information is our volume formula for a sphere. So volume equals 4/3 pi times the radius cubed. But remember, diameter is twice the radius. So d equals 2r. So if I want to simplify that in terms of r, I have to divide d by 2. So d divide 2 equals r. So I'm going to take and substitute that into this formula to change the r to in terms of diameter instead. Now, the next thing I need to do is actually calculate the equation. So I've got 4/3 times 2 to the third power in the denominator. So that's really 1/8. And then next to that, I've got pi times the diameter raised to the third power. And this is our volume. Now, if you ask me any day, I'll multiply fractions long before I'll ever add them or subtract them because it's so much easier. 4 times 1 is just 4. 3 times 8 is 24. So that's really 4/24. This simplifies because we can divide the numerator and denominator by 4. So I really get 1 in the numerator and I get a 6 in the denominator. So my equation simplifies to volume equals 1/6 times pi times the diameter cubed. So part B, write a function that represents the relationship between the mass and volume of the sphere. Explain how you determine the function. So in this case, mass equals density multiplied by volume. If you're in physics, you know a lot more about that than I do, in all honesty. So here, they told us the density was 2,500 kilograms per cubic meter. So we're going to multiply that density times the volume. So we substitute 2,500 for our density. So M equals 2,500 V. So here we go with the composition idea again. Our first function has us calculating volume. Volume is the output. Our second function for B has volume as the input. So an output and an input together open the door for composition. So if I want to know the mass in terms of the diameter. I want to take that 2,500, multiply it by what we already calculated for the volume. So 2,500 times 1 over 6 is 2,500 over 6 times pi times our diameter cubed. So we use the volume to build this formula. But now that's a hidden variable because now we're not talking about volume at all. We're talking about mass in terms of the diameter. So we created our composition function, but we never really needed the volume listed here because it became embedded in this formula. So now it's a hidden variable and that. And so just to get an idea of the context, we could go to our graphing calculator, multiply 2,500 over 6 times pi.